with Marvell at Mobile World Congress 2010, and you're showing Armada 600. Some new things about it. What are you showing about it?
So my name's Kyle Fox. I'm a marketing manager at Marvell, and what we're showing today, what we launched this week, is our Armada 618. This is an application processor that is designed for smartphones, MIDs, portable media players, tablets, all different types of battery-powered devices. And really the 5 key things that you want to know about the Armada 618 is that it has a homegrown, Marvell-designed ARM v7 core that runs at 1 gigahertz. Marvell has an ARM architectural license, which allows us to basically take the specification from ARM and then design it ourselves. We have a lot of engineers that work completely on cores only. This particular one runs at 1 gigahertz. In fact, all of these platforms that you see here are running fully at 1 gigahertz. These 2 platforms are actually running Android Eclair, the latest drop.
So all these 3 are running Android Eclair.
Yes, and Marvell has an extensive amount of engineering resources working on a number of operating systems, from Android Eclair to the Windows Mobile, Windows CE. Yeah. And from a processor capability standpoint, we talked a little bit about the gigahertz CPU. In addition, Marvell has created internally our own video acceleration technology, which we've incorporated into the Armada 618. This is a video accelerator that does 1080p, H.264 high profile, 30 frames per second. It's important to note that high profile is what is used in the Blu-ray players. If you're not high profile, you're not Blu-ray. So you can almost think of the chip as having a Blu-ray player in your pocket. It actually does 1080p decode as well as 1080p encode. So it allows you to do not only play back your favorite movies, home clips, but also be able to use it as a camcorder, maybe a replacement for the camcorder we're using here.
Nice. And the decode of 1080p high profile, is there a bitrate limit in that?
Well, different bit rates are assigned for different content providers. What we'll target to be able to do is up to 20 megabits per second. That's going to be typical to what you would see streaming out into your home. And of course, some of the sites like YouTube will do lower bitrate content to optimize the streaming over the network. But Marvell always wants to be scalable for whatever technology our users are going to apply the technology to.
So you're going to support any H.264 high-profile video up to 20 megabits. MKV container could work.
Absolutely, and you know the prevalence of all the content providers to move to HD content. So YouTube, for instance, everybody knows you go to YouTube, they now have the HD option. All of you are going to move to HD content, not only just for being able to stream it and consume it. Netflix is another good example. But if you think about the personal media recorders that consumers are purchasing now, they film in HD as well. And so what's happening is they're having very low-cost HD camcorders in the hands of consumers that will film, their videos, their home movies, that sort of thing. And all that content in HD needs a place to be played back, and a perfect place for it is inside of a small device like this.
Nice.
In fact, it's a good transition. This is actually a video. It's 1080p, H.264 high profile, 30 frames a second. We're playing this and decoding it at 1080p native resolution, and then we're taking the extra step to scale it down to a WVGA resolution display. Now, what makes this really important is that while we're doing 1080p, we are actually decoding, running FutureMark's 3D MMO6 benchmark. This particular one is being pumped out over HDMI up to the TV, and it's running at 90 frames a second, 90 frames per second. So the way to look at this is we're doing the game at 90 frames per second, we're doing video at 30 frames per second, and I mentioned at the beginning that we have a 1 gigahertz class core in the chip. Right now, the core is not doing anything. It's running the OS and background tasks, but all the work's being done on the accelerators. That means you're going to have great performance at potentially lower power, but also you have what amounts to a 1 gigahertz booster rocket, for instance, to run web browsing or background tasks, etc.
So here the 618 compared to the 610 is the video? What is the difference?
So good question. So between the 618 and the 610, they both share the exact same internal capabilities that we're listing here. The 610 is actually designed a little bit more for additional opportunities in consumer electronics. So for instance, it supports standard PC DDR3 which is typically a lower cost memory compared to low power DDR2. So what that means is our customers can use a cheaper platform in perhaps a tablet form factor, digital picture reader, or digital picture frame, an e-reader, etc. In addition, the 610 has a consumer package, what we call a consumer package. It uses a smaller, less tight ball pitch. This is 0.5 millimeters. What we want to do is produce a package at 0.65, and the benefit for our customers is this chip at 0.5 will build a board in about 8 layers. With 0.65 millimeter ball pitch, we'll be able to do it in 2 layers, not including the power and ground layers. So that means a much less expensive development board for other applications outside the cellular.
But so there's different applications for 610 and 618. It's not everybody should go 18 though.
Absolutely, and the reason why we did both is because we will have different customers that want to do smartphones, they want to do portable media players, they want to do tablets. We've actually incorporated an EPD controller. It's Marvell's second generation EPD controller, and EPD basically means that you're able to drive an e-reader or e-book screen. That's incorporated into 610, so customers who want to build, a very powerful, long battery life e-reader can use the 610 to create that device.
Nice. And how about the video encoding in 1080p? Is there a way to measure the quality of those, like in terms of how much quality you can get per bit rate? Are you very high complexity in the encoding?
Well, as I said, we do 1080p H.264 high profile, which again is the Blu-ray spec.
Yeah.
So almost a Blu-ray encoder in your pocket.
But that's decoding, though.
That's decoding as well as encoding.
So it's high profile encoding.
Yes, absolutely, 30 frames per second. Now, we also have 2 modes within our video accelerator. One that actually would be considered a turbo mode, which will do very fast encoding, but at a higher bit rate. And this is good for those short clips that you want to have encoded quickly. But we also have the ability to do it at much higher quality at higher bit rates. It consumes a little more power at a lower bit rate. Let's try that one again. Yeah, at a lower bit rate. So those 2 modes allow us to do either a high bit rate fast encode or a lower bit rate encode that consumes a little bit more power but gets you a smaller file size.
So it's just more battery power that's being used.
Exactly, and it's basically what the user wants to do. Do I want to do a fast one that doesn't consume as much power, or I don't want the highest quality setting, which will have a smaller size of your file that you may want to put up on Facebook, but it'll have lower battery life.
And you get the same quality.
Absolutely. Marvell's all about scalability and choices, not hard-coded into one particular thing.
But what is the maximum then in terms of how much power can you put in there to get the maximum quality in the lowest bit rate?
Well, how would you measure that? There's a number of people a little bit more intelligent than I am and say that would be able to look at an encoded video and say whether or not this is professional quality, that sort of thing. The way I'll answer your question is that our video technology is used in our Marvell Armada 1000 processor, which is a set-top box Blu-ray capable processor. And by putting that processor and that video technology into that type of application, we're driving actual consumer devices, Blu-ray players, etc. And the only way we would actually be able to be certified to do that would be able to create some of the best video out there on the market.
All right. But so the encoding was typically better if you could use a multi-pass encoding where you don't do the whole thing in real time, I guess. That's still better than doing it in real time. But you can still reach a very high quality in the recording.
Absolutely, and it's there always are ways in which you can take an initial raw video and be able to encode it with different options to get to the best quality that you want. And our customers are creating different devices. A smartphone customer may want to do it at a certain level. They may not even want to do 1080p. They may want to do 720p or D1 resolution, and the video accelerator will scale down to those lower resolutions at lower power. They may want to emphasize battery life. Other customers may want to create the world's best multimedia engine smartphone or maybe even an HD camcorder, and they'll want to turn on every single knob to make the absolute best experience.
Nice. So how soon can we see camcorders with a super high quality 720p encoding? And how long time does it take to get the products out?
Well, we have been sampling our processor to our customers. Of course, we're showing it here with its own reference design. This is how we actually engage with our customers. This is our Armada 610, 618 reference platform. You can see the board that's inside of it. This is how we engage with customers early on. and that process has begun.
Yeah.
And actually, this one isn't crashed. It's actually running up here. It's just simply putting it up to the TV.
Any of those touch Android?
This one right here, this is actually an interesting demo. This is a previous version of the Game Loft. It's Asphalt 4. This isn't the latest version of the game. Let me go ahead and restart the race. There we go. The reason why we chose to show this game is that it's 100% software based. It doesn't use the accelerators. This particular platform, I started running this at 9 a.m. on Monday when the show started, and it's been running flat out at 1 gigahertz the entire time. And what we're trying to show people is that not only can we run a platform for that long at that speed, you get great response. Actually, it's left, right, and clearly I'm not a very good driver. Basically start crashing into a few things, but the point is that this is all running on the main 1 gigahertz CPU, and I know that your viewers won't be able to do this, but I invite you to put your hand underneath it like this.
Whoa.
This has been running flat out for 3 days, non-stop, and yes, it's a little warm from sitting on a table for 3 days, and you can comment on how the temperature feels.
It's not hot. It's fine.
It's fine. So
it's not like the iPhone.
There you go. And so so power consumption is critical in our business. We also want to provide the best performance, but this is an example of how you can have something running for days at a time without burning your hand because of all the heat that's being generated.
No fan.
Yeah, exactly.
Well, thanks a lot.
Okay.
So what are you showing up there?
Okay, so this is putting together all the different concepts. What we've done here is we are decoding in real time 4 independent video streams on the video accelerator. At the same time, we're pushing that, before we display it, we're pushing it through our 3D accelerator, which means that we can texture map the video onto these 3D shapes. So you can count the videos 1, 2, 3, and there's a 4th one on the other side. By making it into a 3D shape, we can do different tricks like this, waving polygon, as well as cover flow examples. You can see the reflection of the video. Hopefully your viewers can see it. Reflections on the video, and we're able to do that because it's acting as a 3D object. So instead of having static images on of your video clips on your phone, think about moving through your user interface and seeing actual animated clips really running, so you know which video you want to be able to play.
It's cool.
And again, this is all running on our accelerators. The CPU is not doing very much work at all.
And each of the videos on what resolution?
All 4 of them taken together, if you added them together, is a 1080p frame. So they're basically quarter HD each.
So you need to generate the video thumbnails.
It actually is not even generating. These are the actual file clips. They're just running. Yeah, they don't even need thumbnails.
But if you have only HD videos, you need to generate the thumbnail before you can move it.
Yes, you would be able to do something lower. Another way of looking at this, these could be 4 video conferences, incoming video conferences.
Nice.
So you're able to select which friend you want to talk to.
Cool. Okay, thanks.
Okay?